In this video, we're going to learn about some features you can add on to functions. Last time, we looked at how to build basic functions, so go watch that if you haven't yet. And for this video, since there's a lot to go over, we'll be using some generic examples that don't have an actual purpose, but the concepts work on any functions you write. Let's start. So I have this function, and it needs a few parameters. When I go to call that function, as I type, the IntelliSense feature in VS Code helps to keep track of the values, but sometimes it can get confusing. Like we learned in the last video, when you call a function and give it values like normal, the order of the arguments matters. The first argument corresponds to the first parameter, the second to the second, and so on. These are called positional arguments because it depends on the position. Instead of positional arguments, you can also give data to functions using keywords. Instead of placing 324 in the third position, we can say arg3 equals 324, arg1 equals 12, and so on. These are called keyword arguments. So you can organize your arguments how you want if you type in the parameter name, an equal sign, and then the value. You can start out calling a function with positional arguments and then end with keyword arguments too. You still need to supply all of the arguments, but you can switch the order this way. Moving on. Look at the following two functions. They're pretty similar. They both take in an amount of hours and return a pay amount. In the first function, you specify the pay rate, and in the second, it uses the US national minimum wage instead. What if we could combine them into one function, where if you don't supply a pay rate, it just defaults to using minimum wage? You can do that using default parameter values. Here's how. Just put an equal sign after the parameter you want, and then the default value. Now we can call it like normal, with hours and a rate, or we can give it just the hours and it'll fill in 7.5 for the rate. Let's test it out. You can set as many default values as you want, but they need to be the last parameters in the function definition. If you try to set a default value, then a regular parameter, you'll get an error. Next up, let's look at the print command. It's written pretty interestingly. We know that the print command will take as many arguments as you want. So how do you define a function to take in an unlimited amount of arguments? The answer is arbitrary arguments. To define arbitrary arguments, just put an asterisk before the parameter name, like this. Now all of the arguments will be put into a sequence with that name. So you can use all of the sequence operators like for loops. Let's test this one out. Again, you can also use regular arguments first, and then arbitrary arguments, but the arbitrary indicator needs to go last. Next up, let's talk about documentation. Up until now, the only option to describe what goes on in our functions is to use comments. However, there's a professional way built into Python for you to describe your functions. They're called docstrings. To add a docstring to this function, put a set of triple double quotes on the first line of your code block, like this. Then, inside of your quotes, say what your command does. For this example, since it just adds two numbers, I'll say, return the sum of two numbers. Now when you go to call this function, or hover over a call, IntelliSense built into VS Code gives you the documentation of that function. You can also use the help command, given the command name, to have the program display the documentation. You can also make the docstring across multiple lines and give extra information about the arguments, return values, side effects, and other details. For the full guide on docstrings, check the official Python Developers Guide on python.org. But for now, a simple description is good enough for our uses. Finally, there are some special cases and uses for functions that you should know. These aren't necessarily new concepts, but they should probably be noted for the future. When we first learned about lists, we called them reference data types. Or basically, when you set a variable equal to a list, it's really just storing a reference to that list, not the actual value. You can see that in this example, when I set y equal to x, modifying y causes x to also change. We learned to get around this, use the .copy command. Well, since lists are reference types, when you go to use them with functions, you'll also get some funny behavior. Look at the following function. It takes in a list, which, by the way, I like to name the parameter collection because typing just list confuses things because it's the name of a Python class. Anyways, this function doubles the value of each item in the list and then returns it. It does this by using a for loop on the range of the list. Remember back to Unit 3. So I have this list x, I call the double function given that list, and then I set that to y. Let's see what happens when we print both x and y. Just like with variables, the value ends up being the same. That's because the parameter collection points to the value of x. Again, we can fix this by using the .copy command and creating a new variable. In general, if you want to write a function that modifies a list, have it copy the list and return a new one. That makes your code clearer to understand. Okay, so let's combine a few of these concepts. Look at the following function. This function takes in a list first and has two other parameters with default values. The purpose of this function is to alphabetize a list, and the two default values are options of the function that modify how it behaves. The first option is whether or not each item should be capitalized. You can see that there's a conditional that checks for that option here. By default, it's set to off. The second option is whether or not to alphabetize in reverse. By default, it's also set to off. You can also see that there's proper documentation, so when you start typing the function call, IntelliSense gives you a description. And finally, since the function uses a list, it copied the parameter into a new variable before returning. Cool. Let's test it out. I'd say this function has the CodeDog seal of approval. Lastly, one of the ways that functions are really useful is that they can be reused between programs. Because they solve problems with patterns, if you write a function once, it can be used a countless number of times in different programs. In the next video, we'll learn how to separate a Python program into different files, and then you'll know pretty much all of what you can do with functions. In the next unit, we'll talk about objects, which is the last big powerful tool you can use to create programs. You might have not realized it, but you're already far down the path to learning Python. Keep it up and keep practicing. CodeDog out.